Welcome back to Forge and Function. You've seen us build the impossible. Today, we build the USS Gerald R. Ford, CVN 78.
Hello, America. Elias Vance here. Creative reinterpretation. Build a $13 billion carrier out of wood.
This isn't model building. This is structural audacity. Replicating the Gerald R. Ford class supercarrier, it's...
The initial challenge wasn't scale, it was integrity. A modern carrier hull experiences immense hydrostatic pressure.
To the River Sid. The original Ford uses over 100,000 tons of high-strength steel. Our Arcawood substitute has to mimic...
The process, refined over 3 years in our Newport News Research Annex, involves high-pressure lamination, 50...
Look here, we aren't ignoring modern tech. The Arcawood structure acts as a massive, non-conductive shock absorber. We've embedded the wire. This reduces electromagnetic interference and protects the sensitive electronics from harsh impacts. It's a giant circuit board built from trees.
After 9 months of continuous construction by a specialized team of American shipwrights and material scientists, the true test of RK-1 isn't its ability to float, it's its ability to perform the dynamic ballet of carrier operations.
We have to test 3 major systems: hydrodynamic stability, structural integrity under simulated launch forces, and the electromagnetic launch platform.
Every millimeter of the wooden Leviathan is mapped. Tens of thousands of strain gauges and thermal sensors.
Load sensors at position Delta 7 nominal. Hull stress below 5% predicted fatigue threshold for Phase 2 testing.
Excellent. Let's initiate the email simulation sequence. Power up the magnetic coils. Let's see if our wood deck can handle the thrust.
The Email-S system, running on a dedicated high-capacity battery bank, generates a force equivalent to launching a fully...
5, 4, 3, 2, 1. Ignition. Launch sequence initiated.
Perfect. No launch, no visible delamination, no stress fractures around the rail housings. The Arcawood acts like a composite spring.
The final, terrifying phase. Baptism. Can a structure made primarily of reinforced...
We've sealed the outer hull with 4 layers of clear polymer resin. It looks like varnish, but it's functionally impervious to water infiltration for decades.
Initiate ballast sequence 3. Monitor tank pressure closely. We are simulating full load capacity.
The simulation calls for a 25-degree roll to port, maintained for 30 minutes, followed by a controlled, simulated stern quartering wave.
The angle is still rising, Elias.
I see it, Maya. We're almost at the critical threshold.
Initiating programmed roll sequence. Adjusting trim tabs. Calm and professional command. Ready for the test.
Look at the damping. It's not fighting the water, it's flowing with it. The slight flexibility of the laminated structure is
Wood expands and contracts. It breathes. Our ArcaWood is designed to maintain that breathability under pressure.
All hands, brace for impact. Secure all equipment. We have approximately 30 seconds until collision.
Incoming wave pattern simulation initiated. Massive cross swell approaching from starboard quarter. Prepare for impact.
Report. Report structural integrity.
Spikes nominal. We hit 92% of predicted maximum load port stanchion. Hull integrity, 100.
That was too close, Captain.
Agreed, mister. Status report on the engines.
We just put a wooden supercarrier through a stress test that would shear the plating off a conventional ship its size, and it didn't even leak.
All systems green. Let's initiate the final sequence.
Activating ArcaWood protocols. Data stream stabilizing.
The ultimate test. Sustained flight operations. Can the wooden deck provide the required flat, durable
Surgeon's workers reverse jerpers. We have applied a ceramic ablative coating derived from volcanic ash onto the flight deck surface. It's designed.
This isn't a landing. It's a controlled, vertical descent onto a runway made of reinforced timber.
Touchdown confirmed. Surface temperature holding steady at 1,650 degrees Fahrenheit. Ablative layer performing above projections.
The ArcaWood breathes. It disperses the thermal energy into the massive structure, which then radiates it harmlessly over the water.
Project Arche was never about replacing the steel fleets of the United States Navy. It was about proving a fundamental concept.
We built a marvel of modern engineering using the bones of the forest. The USS Gerald R. Ford is a monument.
From the forests of the Pacific Northwest to the deep waters of the testing range, Project Arche is complete.
Join us next time as we explore the possibilities of bioluminescent hull coatings.
We did it! Project Arche is a success.
Wire team, check tension on 3.
Roger, tension checked. Green deck, proceed with taxi.
Yes!
Main engine ignition confirmed. Look at her go! We did it, we did it!
Everything is prepped and ready for phase 2.
Yes!
We did it! We did it!
The ablative layer sacrifices itself, creating a protective char that shields the substrate from the intense plasma flow.